Another type of question will change the condition. So for example, you won't just have one pressure, you'll have two pressures, two volumes, two temperatures. The only thing that's constant in PV equals nRT is the gas constant R. So what I've done here is I've solved for everything that could possibly change. So if I am carrying out an experiment at one pressure, one volume, one number of moles, and one temperature, I know that that is equal to the gas constant R. If I change those variables, I can change the pressure to P2, the volume to V2, the number of moles, and the temperature also change, but that still equals R. So if both of these equations equal R, these two have to equal each other. So this version of the equation comes from PV equals nRT, but it's used when you're changing from one condition to a second condition. For example, what's the final temperature in Celsius if a sample of gas changes from 2.15 atmospheres to 4.3? The volume is constant, and when the volume is constant, we don't care what V1 is because it'll cancel out with V2. Also, notice the problem doesn't say we gained any moles or lost any moles of gas, so N1 and N2 are the same. So we're left with P1 over T1 equals P2 over T2. It doesn't matter which one you call 1 and 2. Say the first pressure was 2.15 atmospheres. The first temperature was 0 degrees, but that's in Celsius. We can't plug in Celsius, we have to translate that into Kelvin. The second pressure, 4.3, and the only unknown is the second temperature. If you solve this equation for T2, you'll get 546.3 Kelvin. In order to make the pressure go up, the temperature had to go up because the volume was constant. So a larger temperature than the initial makes sense. But notice the question asks for this in degrees Celsius. So now we translate back from Kelvin into degrees Celsius, and this one coincidentally is the same number as in the conversion factor, 273.15 degrees Celsius.